In this recording, we will be looking at the coordinate geometry topic of parallel and perpendicular lines. Let's start with the parallel lines. So what do we know about parallel lines? Parallel lines never touch. So it doesn't matter how long I continue these lines, they never touch because they are the same steepness. They have the same gradient. So if this represents the equation of a straight line, y equals 5x minus 3, I will ask you to come up with an equation parallel to this line. Okay, well now, parallel lines have the same gradient, so as long as the gradient remains the same, it doesn't matter about the y-intercept. The gradient of this line here is 5, so the gradient of our second line needs to be 5. So it could be any equation with the same gradient. These would all be parallel lines because they would have the same steepness. Write down the equation of a line parallel to y equals 2x minus 1 and passing through 1, 8. We need to write down the equation of a line. So let me write down the general equation for a line, which is y equals mx plus c. Okay, well, if our line is parallel to this line here, these have the same gradient, so m has to be 2. So we know y equals 2x plus c. Okay, but we don't know the y-intercept. How can we find the y-intercept? We know that the line y equals, no we don't. We want our equation of the line to pass through this point. So we know the point 1, 8 lies on our new line. These are the coordinates, right? X coordinate, Y coordinate. So we can sub these into our equation. Let's see the subject now. Let's take 2 from both sides. So our equation is y equals 2x plus 6. Okay, have a go at these 4 questions yourself. Put me on pause, see how you get on, and unpause when you have finished them. Y equals mx plus c. They have the same gradient, has to be 2. X coordinate and Y coordinate, which is on the equation, which is on our straight line, so we can sub them into the formula. Let's see the subject by taking 6 off both sides. B. Parallel, so our M is -4. X coordinate, Y coordinate. This is meant to be a C here. Take 8 off both sides. So we have Y equals -4x minus 1. Okay, part C. Gradient is 5. Let's sub in these points, these coordinates. Let's take 5 off both sides. So y equals 5x minus 8. Last one, part D. Gradient's -3. Add 12 to both sides to make C the subject. So we have y equals negative 3x plus 7. We will now look at perpendicular lines. So the red lines all have their perpendicular drawn in purple on each graph. So perpendicular lines cross at right angles. Now let's just investigate these gradients. So the gradient of the red line, 1 divided by 1, 1 here is 1. Negative gradient because it's going in the opposite direction. 1 divided by 1 is negative 1. Okay. So you can see always with the gradients, one is positive and one is negative. Let's get these gradients here. So height 2, base 1, 2 divided by 1 is 2. And what about this gradient here? Negative 1 divided by 2. Okay. And here we have 3 divided by 1 is 3. And this one here, well, it's negative 1 over 3 is just minus a third. So if you notice, okay, if you multiply the gradient with a perpendicular gradient, you get negative 1. Minus half times 2 is negative 1. Minus a third times 3, negative 1. This always happens with perpendicular gradients. If you multiply the gradient of one line and it's perpendicular, you do get negative 1. So maybe note down this fact. Perpendicular gradients multiply to give negative 1. Okay, so write down the equation of a line perpendicular to each of the following. So our gradient for this line here is 4. We know 4 times the perpendicular gradient is negative 1. We make m2 the subject here. Divide both sides by 4 minus a quarter. So our equation of a perpendicular line is y equals minus a quarter x. Doesn't matter about the y-intercept, let's say plus 1. Let's look at b next. Well, this time our gradient is negative 2 for m1. The negative, so we know m1 times the perpendicular gradient is negative 1. Let's divide both sides by minus 2. We got a perpendicular gradient is a half. So the equation of the perpendicular could be y equals a half x plus 5. I'm just choosing any intercept here, it does not matter. Okay, next one, part C. Our gradient here is 1/3. I know 1/3 times m2 is negative 1. Divide both sides by divide both sides by a third. We get m2 is minus 3 because minus 1 divided by a third is minus 3. So the equation of our perpendicular and last one here, our gradient is 2/5. We know 2/5 multiplied by our perpendicular gradient is negative 1. So m2 is -1 divided by 2/5, which is -5/2. So y equals -5/2x plus 1. Okay, now we need to write down the equation of each of the following lines. Well, we're just doing the one line. Perpendicular to y equals 2x minus 1 and passing through 4, 0. Gradient here is 2. 2 times our perpendicular gradient is -1. Divide both sides by 2. Our perpendicular gradient is -1/2. We want the equation of the line, though, perpendicular passing through the point 4, 0. So we know that m is -1/2. We also have a point on our line, x coordinate, y coordinate. -1/2 times 4 is -2. Add 2 to both sides. So our final answer is okay. So have a go at these 5 questions. Put me on pause and pause when you have completed. Okay, so question 1. We have the gradient is -3. We know perpendicular gradients multiply to give us -1. Divide both sides by -3. Gives our perpendicular gradient 1/3. Y equals mx plus c. So 1, because you've got your y here and your x here. 1 equals 6 times 1/3 plus c. Let's make c the subject by subtracting 2 off both sides. So the equation of the line is y equals 1/3 x minus 1. Question 2. Our gradient is 4. Perpendicular gradients multiply to give us -1. M2 is -1/4. Y equals mx plus c. We have an x coordinate and a y coordinate. Question 3. Divide both sides by -1. Sorry, -1/2. -1 divided by -1/2 is 2. Sub in our x and y value. Take 6 off both sides. Question 4. Divide both sides by 2/3. Take 9 off both sides. Last question. Divide both sides by -3/5. -15 off both sides.